Hi everyone, welcome back to Life Technologies channel and thank you for watching. So today we are continuing with our Huawei Lab simulation series, and today our focus will be on how to implement OSPF virtual links on Huawei routers. So on a standard OSPF network, we need to ensure that we have connectivity all the way from non-backbone areas to the backbone. So the non-backbone areas should have a connection to the backbone. That should be a physical connection, but sometimes it's very hard to achieve the physical connections for all non-backbone areas. So that's why we need to implement the OSPF virtual links for the areas that are not directly connected to the backbone areas. For example, in our setup, you can see we have three areas: area 0, area 1, and area 2. And area 2 is connected to area 1, which is connected to area 0. So in such a setup, we need to create a virtual link for area 2 to be able to have connectivity to area 0. So the implementation steps for this lab will be first to configure the system name and interface configurations as usual. And then the second step will be OSPF configuration on all routers. Once we've configured the OSPF, we need to verify that we are having communication issue between OSPF area 2 and OSPF area 0. So like a router like R7 will not receive any routes coming from other areas, for example, area 1 and area 0. Once you verify that we have disconnectivity between these two areas, we need to now implement the virtual links. And then we do final verification to ensure our virtual link is up and we are having connectivity from area 2 to area 1 and area 0. So let's start our lab. As you can see, we already have the setup ready on ENSP that we are using to simulate Huawei routers. And we have IP addresses assigned. We have the loopback 0 IPs, which we are just using the router number. For example, router 1 will be 1.1.1.1, and we are using /32 IPs. And then we have the point-to-point also as shown. So for the configuration part, the first part, as we mentioned, is to do interface configurations and even the system name, so that we have names like we are naming the routers as recommended. Many times these names you assign as per your organization requirements. So once you've given the name to the router, we are taking a different approach. We are configuring the router ID globally on all the routers. So you can see on router 1, we are configuring the router ID as 1.1.1.1. On router 2, we'll be configuring the route ID as 2.2.2.2. So we are configuring the route ID using the loopback 0 IP. So we create the loopback interface, and then we assign IP address. We also create the point-to-point connection, the interconnection between the different routers, and we assign IP addresses. So these are the configurations on routers R1, R2, R3, and R4. And then we have the configurations for R5, R6, and R7. So you just assign a system name, you configure the router ID to be the loopback 0, and then you configure the loopback interface and you create the interconnected interface, the interlinks between the different routers, and assign IP addresses. And also it's a very good practice to give descriptions. So once we've finished interface configuration, the next step is OSPF configurations. So for OSPF configurations, given that we have globally configured the router ID, we really don't need to configure the router IDs on these routers. It will be picked from the globally configured router ID. So, and these are the OSPF configuration for all the routers from R1 to R7. So R1, we are configuring OSPF process IDs 10. And then under area 0, we are advertising the networks, the loopback 0 and the interconnected interfaces. So we do same configuration on all the routers and advertise the necessary networks that we need to be able to reach from the other OSPF areas. So as you can see on R4, we are configuring area 1 because R4 is only in area 1. Then on R3, as you can see, we are configuring 2 areas because this one is the ABR, the area border router, because it's between 2 areas, area 1 and area 0. So we advertise the networks respectively. Then on R5, we are doing the same. It's an ABR connected to 2 different areas. So we advertise the networks in area 1 and area 2. Then R7 is only in area 2. So we only advertise the networks in area 2. So once we finish this configuration, we can verify that our OSPF peering is up on these routers. If I do display OSPF peer, you can see we have 2 peerings. 1 to 5.5.5, this is router 5, and then 1 to 3.3.3.3. I can display IP routing table, protocol OSPF, and we can see we are learning the routes from OSPF protocol, and all these details are provided: the protocol, the preference, the cost, and the flags, the next hop, and the exit interface. We can display OSPF interface. So networks with these addresses, the interfaces with these IP addresses, with these networks will be OSPF interfaces, because remember we are advertising the network and not enabling OSPF on specific interfaces. So if we check on R6, I run the same command, display OSPF peer. We have 2 peerings, one in to router 7 and another one to router 5. Router 7, it's area 2. This one is also area 2, because this one is an internal router. On R3, we expect to have 2 peers also, one in area 0 and another one in area 1. This is an ABR. Can display IP routing table. We have OSPF routes coming in from other areas. This one will have OSPF routes coming from area 2, and this is area 1 and area 0. But if we check on R7, if I display OSPF peer on this router, you can see we have 1 peer. But if I display IP routing table, you realize that we only have routes from area 2. We don't have any routes coming from either area 1 or area 0. So that's why we need to implement the virtual link to ensure that we have connectivity from OSPF area 2 to OSPF area 0, but it should be via area 1. So the virtual link is implemented on area 1 to enable us to have connectivity between area 2 and area 0. So for the virtual link configuration at the symbol, we just need to configure on R3 and R5 the boundary routers for area 2, for area 1 that is. So on R3, we'll do system, then configure these. So we've configured on R3, we need to do the same on R5. R5 system, then we do the configuration for virtual link. You can see even the logs indicate that we were having a virtual link configured and the neighbor previous state was down, but it's now up. So we can display OSPF virtual link, and you can see the virtual link neighbor ID is here, and then the neighbor state is full. And the transit area, it's area 1. On R3 we can do the same. I do display OSPF vlink, the neighbor state is full, and then the transit area is still area 1. State is, and type is virtual because it's a virtual link. So now if we check on R7, if I do display IP routing table, you realize that we are now having routes from all the other OSPF areas. So which means our virtual link is now working okay, it's up. And remember, when you are doing the virtual link configuration, you need to do both sides. You need to do on R5 and also on R3. You can't just do on one router, it will be down, the state will not be full. So now we are having the routes. And we can ping 1.1.1.1. So we have communication end to end. If we check R1, display IP routing table, we have the routes coming in from area 1 and area 2. So this is how simple it is to implement virtual links. You just need to specify the vlink peer under OSPF in the specific area that you want, and then you do similar on the other side of the router, and you will have your virtual link up, and then the routers will be able to exchange routes accordingly. So guys, this is it for today. Thank you for watching again. If you have any questions, remember to comment and we'll reach out. If you require the script or you need any support, just feel free to leave a comment. And also remember to subscribe to our channel. Thank you.